This video is about something called the angle bisector theorem. When you have a triangle with a segment that is splitting one of the angles in half, that's called an angle bisector. You can tell that the angle is being split in half because of the way that the two sides are marked congruent. When you draw an angle bisector, it turns the larger triangle into two smaller triangles. Now, even though this unit so far has been all about similar figures, the two smaller triangles are not similar to each other. However, two pairs of proportional segments are created. Let me show you what I mean. Okay, so if this is an angle bisector, then that would mean that this angle would be congruent to that angle. Alright, so that's how I know it's an angle bisector. Now, consider this. Let's call this A, and let's call this B. And let's call this segment X, and we'll call this segment Y. Okay, so please understand, I'll just put a little dot right here to break up this bottom. Segment B is the left portion, alright, of this side of the triangle, and segment Y is the right portion of this. So according to the angle bisector theorem, the following segments are proportional. A over B will equal X over Y. So it just lines up very nicely. Just A over B is equal to X over Y. So for problem number 1, we can use the side splitter theorem to find the length of the side that has a question mark. Alright, I'm going to go ahead and put an X right here instead of a question mark. So when you do your angle bisector theorem, just make sure you'll make one fraction out of these two, and then you'll make another fraction out of these two. It's really sort of just they're separated by that angle bisector. So your proportion could be written this way: 21 over X will equal 15 over 30. Alright, you could have done X over 21 and 30 over 15 if you wanted to. That part doesn't matter. So if I do 21 over X, I always like to reduce these. Both of these are divisible by 5. So this is going to be 3 over 6. Actually, that would reduce down to 1/2. Looking back, 15 goes into 30 evenly, so I should have noticed that immediately. But anyway, this will simplify down to 1/2. And then you cross multiply. So if I do this diagonal, 1 times X is really just X. And then if I do the other diagonal, 2 times 21 is 42. So the unknown side is 42. Before we do the next problem, it's time to have another quick talk about the relationship between two parts and the whole. So for example, if I know that this is 10, alright, if the whole is 10, and if I tell you that this part over here is 6, then and then I ask you for an expression for the other part, you can tell me very quickly that it is 4. Now the calculation that you just did, even if you didn't realize it, is you were doing 10 minus 6 in order to get this. Alright, so that's important because let's say if this was X, alright, say if we didn't know that this was 6, then the other part would be 10 minus X. Okay, so it's the if you are given the whole and you have an expression for one part, then the other part will be the whole minus the part. Okay, now on the other hand, what if the whole is a variable. Okay? And then let's say I tell you that this part over here is 10. Now I need an expression for the other part. Well, it's still going to be the whole minus the part that you have. Okay, so this would be x minus 10. Okay? So if you need to, you can think of the whole thing as a formula. If you need to find part 2, then part 2 is always going to be the whole thing minus part 1. So that's going to come into play on this problem right here. Because we need to find part 2 over here, all right? In order to do the angle bisector theorem, we need both of these segments. But we have this unknown, okay, for the whole. So we know that part 2 is going to equal the whole minus part 1. Okay, so in this case, that means that part 2 is going to be x minus 7. Alright, the missing part is going to be the whole thing minus the part that we already have. So it's going to be x minus 7. Alright, so now I can go ahead and do the angle bisector theorem. So I'm just going to make a fraction out of these two, and I'll make a fraction out of these two. Okay, and notice the two fractions are basically separated by the angle bisector itself. So that's going to give us 7 over 28 is equal to x minus 7 over 20. This reduces, all right, these are both divisible by 7, so this is going to be 1 over 4 is equal to x minus 7 over 20. And then we will cross multiply. So if I do this diagonal right here, okay, that is going to be 4 times x minus 7 equals, and then if I multiply along this diagonal right here, well, 1 times 20 is just 20. So then a little distributive property happens, and we see that 4x minus 28 is equal to 20, and then you would add 28 to both sides. So that's going to give you 4x is equal to 48. Alright, then it's time to divide both sides by 4. And that's going to give you x is equal to 12. Alright, so looking at number 3, using the angle bisector theorem, we'll just make a fraction out of these two, and we'll make a fraction out of these two. So that means 14 over 21 is equal to 10 over 2x minus 5. Let's see. Both of these are divisible by 7. So that's going to be 2 over 3 is equal to 10 over 2x minus 5. Now I will cross multiply. So if I multiply along this diagonal, that's 2 times 2x minus 5. And if I multiply along this diagonal, that's 30, so equals 30. Distributive property gives me 4x minus 10 is equal to 30. Add 10 to both sides. So 4x is equal to 40. divide both sides by 4, and we get x is equal to 10. Okay, and this is another one of those problems where we have to find part 2 in order to do the problem. So remember that part 2 is always going to be the whole thing minus part 1. So that's going to be 39 minus 24. Okay, so now I can do the angle bisector theorem. I'm going to make a fraction out of these two, and I'm going to make a fraction out of these two. Okay, notice again that the two fractions are separated by the angle bisector itself. So that's how you know which numbers to put together in your fraction. Okay, so I can do, for example, 5x minus 5 over 15, and that should equal 48 over 24. This will definitely reduce. Both of these are actually divisible by 12. So this is going to give me 5x minus 5 over 15 equals, and so this is going to be 4 over, oh, you know what, I started to say this is going to be 4 over 2, but then I'm like, well, that reduces even further, because 4 over 2 is just 2. And then I felt silly, because of course 48 is divisible by 24. So I should have done that in the first place. Alright, so both of these are divisible by 24. So that's going to give me 2 over 1, if you will. And then I will cross multiply. So if I do this diagonal, that's just going to give me 5x minus 5. Alright, because multiplying by 1 doesn't change anything. And then if I do this diagonal, multiply this diagonal, that gives me 30. So then I'm going to add 5 to both sides. Sad little 5. Then that's going to give me 5x is equal to 35. And then I would divide both sides by 5. And that's going to give me x is equal to 7. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.